Hey, good morning, Warriors. Hope you're all doing great. Just as a reminder, our last homework is due on Sunday. That's Pearson 3 Bravo and 3 Charlie on X, R, P, and C charts. So looking at today's map check, the red arrow is where we are. I'm going to do just a little bit of we drive practical work on P and C charts, get our hands dirty a little bit. And one more reminder about the last homework due this coming Sunday. Looking ahead to next week, on Tuesday, we'll have just an overview on total quality management and lean. We're not going to work any problems out of that per se. We will have some material that's on our final from that. We'll talk about what that's going to look like. But for the most part, it's really concepts more than mathematical problems there. And then a week from today, we'll have our final Zoom session. We'll start off by doing a class photo on Zoom. That'll be kind of unique. And if you want to participate in that, that'll be up to you. I always like taking a class photo on the last day of class. So we have that to remember. But more importantly, we'll get ready for the final. We'll talk about what's going to be on the final. We'll do a little bit of we drive action. If there's things you would like me to review before now and then, please let me know one way or another, preferably email, carrier pigeon, Jedi Knight telepathy, some kind of way of what you would like me to go over. Friday the 8th, two things are happening. One is class interaction and participation assessments. I'll post those on Canvas. And then reading day reps, I'll just go ahead and talk about that. Where's my mouse? Come here, mouse. Right now. So reading day reps, again, it's purely optional. If you want a little bit of last minute love, you can sign up for a spot. Right now, everything is open between 9 to 12 and 1 to 3. So if you want a 30-minute slot with me one-on-one to go over some problems, to go over stuff that's giving you issues and difficulty, then let me know. Email me. We'll do it on Zoom. We'll have a good time. If you don't want to do it, you're cool. You're good to go. You can spend your time doing something else. That's cool too. That's all up to you. Here's what we're going to do today. We're already recording. We're just going to get right down to business in the PNC charts. Before we do, any questions, big or small, on anything from anyone?
Is the final going to be open? No, like the last test was.
Yes.
And is it cumulative or is it just this stuff that we've done?
So it's mostly the stuff that we've done in this last block.
Okay.
Because you all have done really well all year, there's not a thing that pops out to me from block 2 or 1 that we really need to revisit. In the past, with some sections of Warriors, there's been one thing along the way that somehow we just kind of didn't get straight. Probably more my fault than anything, that we put on the final just to get another pass at it. I don't see that as obviously with you all. So I'm still kind of figuring out in my mind. But you can count on the 6-pack stuff that's predicting inventory with probabilistic demand. You can plan on some sort of MRP. You can definitely plan on all the control charts, X, R, P, and C, and then a little bit of lean TQM stuff in there.
Cool.
Okay.
Thanks.
Does that sound good? Okay.
Yep.
All right. Other questions, big or small, before we begin the fun today? All right. Let's get down to it. Okay. So this Excel series is on your Canvas. If you want to split screen, pull it down, follow along, whatever. And we're just going to get right into it. So let's check it out. Dark Knight controls part 2 as part of his post-patrol routine. So Batman goes out all night. He patrols Gotham City. And just before he comes home, so it's probably like 5 or 6 in the morning, he throws a batarang It looks like a boomerang, except it doesn't come back to you. It's kind of like a throwing star kind of deal. He throws it 500 times at a target down there in the Batcave. And of course, his goal is to hit the target every single time. Now, lately, Batman is a little more obsessed about his performance than usual. So, to see how he's doing, he records his misses for 20 days. Only the times that he misses, not the times that he hits. And here's what his performance looks like right down here. He's got the first 10 days and then the second 10 days and the amount of times that he missed every day. So let's go over here. So let's see here. Hannah, what is Batman's sample size? Hannah, you out there? All right, Trevor, what do you think? What's Batman's sample size?
Wouldn't it be the 20 days?
Yeah, so that
Or would it be
go ahead.
1 second. Or would it be, yeah, it's just 20, correct?
You tell me.
Because
What
we're
do you think it is?
sampling, well, actually, no. It'd be the 500.
Okay, 500 sounds better to me.
Yeah.
So I'm just going to hang this up here because 20 days, Chris, what is 20 days?
Wouldn't 20 days just be how many days you just recorded? Like, I'm not actually sure the 20 days would be, but it does give us 20 days worth of the information.
Okay. So 20 days is really kind of corresponds to Q2, which is the number of samples. But the bottom line is the number of samples is not the sample size. That's what I'm trying to drive home here. So he took a sample every day, but the sample size every time that he took a sample is 500. Okay. All right. So Q1 and Q2 is just to, again, have you wrestle with that a little bit. So, Josh, what do you think? Q3, what type of control chart do we want to use here? X, R, P, or C with this data that we have?
We want to use the one that uses sample size. So from what I remember, I know it's P or C, but we go P. I think it's P.
Okay. Tim, what do you think?
Yeah, it would be peak because you're going to take the number of misses divided by 500 to get the percent and then use PUR from there.
Okay. So that sounds good to me. We're not really looking at mean performance. So it's not really X or R because we don't have an average performance here. We have discrete numbers. And these are categorical variables. Either he hits or he misses the target. So it's not a continuous variable. So, and then on top of that, as Josh and Tim just said, we do have a sample size, okay, which is N. So out of those four, we definitely want to pick P. And moving on to Q4. So Q4 says using a Z of 3, choose and depict the appropriate control chart based on the information provided. So I'm just going to hang my Z of 3 right here. And let's see. So AJ, if you were going to control my cursor and my screen, what would you do to start getting started on this control chart?
I would take the average of number of misses and then take that number and divide it by the 500.
Okay. So let's see here. I'm just going to free up some room. Now, what I don't like personally about how I've arrayed this data And you may go, well, why'd you array it that way? Because I want you to kind of think about it. I'm going to put it like that. Not done. There. I don't need this anymore. Okay. So what were you saying, AJ? What ought I to do?
I would take the average of number of misses, and then whenever I get there, I would take that number and divide it by the 500.
I'm curious to see what we're going to get if we do that. So 6.15 and then divide that by 500. Okay.
Then you do P bar plus 3. I mean, yeah, plus 3.
P bar plus 3?
Yeah.
Okay, let's hold that thought. Allie, what do you think we ought to do? So we have these numbers here. Do we need to do anything with these?
Yeah, I created a column next to the number of misses with the sample size of 500.
So, like right here?
Yeah.
Okay. So what'd you call this column? Did you call it anything? Did you call it Emily or
I just said sample size.
sample size?
Yeah.
And you put 500 all the way down?
Correct.
All right. Okay. And then what'd you do? Anything else?
And then I took the number of misses divided by the 500.
Okay. And you put that over here?
Yes.
Something like this. Something like that?
Yes.
Okay. And then you took the average of all these?
Yeah, and that will be your P bar.
Okay. Interestingly, it's going to work out to be the same thing that AJ just came up with.
Right.
Okay. All right. So we're going to need these values sooner or later. We're going to need to plot those. We could call these the proportion or fraction. Okay. Someone's got a mic on. It's causing an echo. I don't know if everybody else hears it, but okay, cool. Let's see. JT. So I've got this P. What should I do next with this P? P bar.
To be honest, I'm not really sure, but I know if you take it and you subtract that from 1, that would give you average percentage.
That is the average. That's what we call the mean fraction. So what I have my cursor on right now, that box, that is the mean fraction in this case of misses. I don't know if I want to subtract that from 1 though. It's not like a p-value or anything like that. AJ talked about upper and lower control limits. So Gilbert, how would I establish this upper control limit that I need?
Can you hear me?
I can hear somebody.
Can you hear me? Sorry, it said my connection's unstable. I can hear you now.
Okay, so
You're saying AJ mentioned upper and lower.
yeah, so how would I establish an upper control limit?
Hmm. Well, if we have, if Z is 3, then I think we take the P bar and do something with that and 3 to get the upper, and then to do lower, maybe so it's like 3 minus the P bar, and then -3 minus P bar to get the lower.
Okay, so we're on the right track. Let's see. Brandon, what do you think? How do we get that upper limit?
You there?
I'm here.
All right, everything's frozen on my screen, and I can't.
Okay, Brandon, can you tell us how we get the upper limit? Teresa, what do you think? How do we get the upper limit?
Oh, sorry. I actually didn't hear the question. It started to rain really hard here and I had to go close my window really quickly. Could you repeat the question?
Yeah. So we need to establish some control limits for this control chart. So how do we determine the upper control limit on a P chart?
I think somebody had just said what I was thinking too, that you do the Z and then the plus or minus the P bar. I was looking through my notes to try to figure out what it was though. So I'm not sure.
Okay. Ethan, what do you think? Ethan Locker.
It's the formula that we went over yesterday. So the P bar plus or minus Z times the square root of P bar, and then in parentheses 1 minus P over N.
Okay. That sounds right to me. Not that train wreck. So again, control limits for a P chart, we got P bar. Is that what you had, Ethan?
Yep, that's it.
Okay. So we're going to use this. We're going to use the adding part for the upper and then the minus part for the lower. So let's see. I got my Z of 3 right here. If I wanted to break this out evenly, I could say something like, I don't know, a P delt. And a P delt could be the square root. I'm going to need a couple brackets. So P bar times 1 minus P bar over that N. And I think I'll be okay PEMDAS wise with that. Maybe not. That looks right. Of course, I'm going to need to take that times Z. So to put this down here, I'm going to say P bar plus Z times that thing right there. What's wrong with that? Nice. Something's going on. Ghost in the machine. Let's start over. All right, I'm just going to do it all right down here. So P bar plus Z times, I'm just going to do it all right here, the square root of P times 1 minus P over N. Probably need a couple out there. Something's going wrong. All right, let's just break it down. I think that looks right. So let's say Z times P delt would be that times this stuff right here. And then I have it all in one spot. And then all I have to do is add that to that. Why? What is this circular reference thing?
Just don't put it right underneath the numbers. Like you have to like have a line. I think that happened to me, so I moved it down.
So like move this down, Emily?
Or just move the upper one down like a few lines so it's not right underneath the, or just do it in a different box.
Like over here?
That's what I did and it worked, so
Huh.
yeah.
Okay, cool. All right, so let's try this again. Boom. Okay, so Jasmine, what do you think about this lower control limit? Any thoughts?
I think that it be a negative, so like you'd like default to 0 because it's negative.
Yeah. So on a test, stuff like that, just you could put 0 out here next to it. And that way I know you did the correct computation, but you're not going to use that value because there's no such thing as a lower control limit of 0, or excuse me, of a negative number. We're just going to default to 0 when that happens. Okay. All right. So, Emily, what should I do now that you helped us get straight? I got my lower and upper control limits. What's maybe another thing I should do now?
Well, first that was Ellie talking to you.
Ah,
It
okay.
wasn't me.
You got credit for it.
Yeah, that was Ellie.
Okay.
You should plot those decimals on a scatter plot.
Okay. So I'm gonna grab those, go up here. I could use that, or I could connect them. I'm just gonna connect them like that. And let's see here. I still kind of want to see that stuff, but I'm just going to throw that right here. Okay. Get some lines. 0.0123. Looks like that's like about right here. All right, for that bottom one, I'm just going to rest it right on the x-axis. Boom. For this top one, 0.027 looks like it's about right there. Cody, what am I going to do now? Gary, what am I going to do now?
You're gonna circle the ones that are out of bounds, so it's just that one up top at day, was that 14?
Okay.
Yeah, 14.
All right. And let's see, day 14. That's this day right there. Up too dark. And yeah, it sure is above that control limit. So something's going on there. Ethan Green, anything below the lower control limit?
There's a no, it doesn't look like it actually.
Okay. This day's right on it.
Yeah.
It's not below it because we can't have anything negative, but this day kind of stands out because we had no misses on that day. So it's not out of control, but man, that was a really pretty stellar day that Batman was having there. Okay, so let's look at this over here. Let me get rid of this. So Teresa, based on the chart, what is your analysis of Batman's performance? Is his performance in control or out of control?
I would say that his performance is in control because there's only one outlier. Because in order to be out of control, doesn't have to be 3 outliers in a row.
Yep.
Okay.
So he has some variation here, but really in the grand scheme of things, and especially by our definition of control, this is normal variation. Some days he's going to have better days than others. And then when we look at Q6, on which days may have Batman been using Mad Skills, a high-powered energy drink? What do you think, Chris? What day you think Batman was using this energy drink?
That would be on the day that he had 0 misses because he didn't miss a single target.
Yeah, very good. So again, that's the reason I bring that up is because is his performance out of control for that day? Well, technically, no, it's not. And Chris identified it correctly. But seeing whether things are in control and out of control isn't necessarily bad versus good. It's more kind of out of the ordinary. And sometimes out of the ordinary does mean that this is adverse performance that we want to stop. But in this case of this day right here, that's something we want to explore for the purpose of continuing that type of performance. So if Batman really has this kind of response to Mad Skills, maybe he wants to drink it all the time, or at least a lot more than he does. At some point, he'll probably become sensitive to it and it won't make a difference anymore. But maybe he drinks it before he's about to go out for a big fight or something like that. So, but the bottom line is that his overall performance, by our definition of control, is in control. Okay, super. Any questions from anyone on any of the process that we went through here? Formulas, procedure, anything like that at all? Okay, this step that Allie took, there's nothing wrong with that. She did that, I'm guessing, and made sure she was bulletproof and she had those computations correct. AJ did something I really wasn't expecting. He got the same answer. So AJ didn't start by adding this column, but he took the average of these and then divided that by 500, which procedurally, I'm pretty sure, gets to the same answer. So procedurally, I think that is sound. Remember, I told you the other day that there's a slide on Canvas that I shared with you. And I just teach this way, where we establish this column with these fractions and then take the average of the fractions, because in my mind, that's a little bit clearer. But again, pick your poison as long as it's procedurally correct. Okay. All right. If there are no more questions on this, we'll go on to the second one. So here we have Dark Knight Controls Part 3. And let's go right here to our white box. The American Civil Liberties Union, ACLU, which, by the way, is a real thing, I didn't make it up, has been very vocal about Batman's vigilante approach and heavy-handed tactics. After all, Batman routinely puts bad guys in the hospital on their way to jail. So the ACLU, for those of you who aren't familiar with this organization, they do things like protest the death penalty and stuff like that. So, of course, they would have a problem with Batman going around and beating people up, even though it's for a good cause. So Batman's not overly concerned about this, but he has asked Alfred, who we all know is his butler and really his operations manager. Alfred has some mad skills in ops management. He's asked Alfred to scour the local social media sites for the amount of daily negative comments that may have appeared. So on Twitter, on Facebook, on Instagram, other social media platforms, Batman has said, hey, go take a look at the last 30 days and see how many negative comments I've got. So Alfred goes back. It probably takes him about 15 seconds to do this. And he gets all this data down here. So here's the first 7 days. Here's how many negative comments Batman got per day, so on and so forth. So here we have a series of questions, and let's just start off here. Q7. What is the sample size in this problem? So, Luke, what do you think? What is the sample size?
It would just be adding up all the no content, or MC, I guess. So 5, 6, 7, 16. Or for that one, I don't know. So for all the days.
Okay. So let's see here. Gilbert, what do you think the sample size is? Gilbert, you out there?
Yeah. I think the sample size is 30. And again, because if you add up all the NCs, I mean, you could break it up like into like 5 sections, like you did. So the sample size could be 5.
Sample size could be 5.
I mean, because you like broke it up into like 7-day sections. And so I'm thinking like each section counts as a sample size. And each like cluster of days counts as a sample size.
Okay. Kylie, what do you think?
There isn't one, just because they are going on the sites to just see who left any comments. So there's not an actual sample that they have that they're taking.
Okay. So Kylie is correct. There is no sample size because Alfred and Batman are not sampling. There's no N provided in this narrative. Like Kylie explained, they're just going on social media and seeing. So it's an open-ended thing. And to reflect on our instruction on Tuesday, it's like me working at the hotel desk. And when people check out, they tell me if they had a complaint, but I don't necessarily ask them. Okay. Or maybe Myra is working the desk and I come by every often and say, "Hey, Myra, have we had any complaints today?" And she goes, "Yeah, there was a couple people that had a problem with the temperature of the water, but we're not actively sampling." Okay. So Q8, what is the sample size? And Q7, or excuse me, Q7, what is the sample size? And Q8, what is the number of samples? These are trick questions. All right. Because it's an open-ended thing. There is no sample size. So based on that, Myra, what chart do we want to use here? So Q9, what do you think?
I want to use the C chart.
We want to use the C chart. That is correct because we have an open-ended situation where this input, these aren't errors, these are complaints in this instance, but they're just coming into the system. Okay. So we're going to use a C chart. So Ames, what's a next thing we want to do here?
You could either graph the chart or you could establish your control limits.
Okay. So pick one. Which you want to graph?
Yeah. So you just highlight that and then insert plot.
Ugh. I'm going to connect these things. That looks a lot better. Okay, so I can see right off the bat that something's going on right there. Okay, so we have our graph. Ethan Locker, what should we do next?
We gotta determine our C bar.
Okay, how do we do that?
That is the average of all the complaints.
Okay, so we take that right there. 2.43.
Yep.
All right. Now, I'm just going to move that out here so I don't have what happened earlier. And I have some room here, so I'm going to move it up. Okay, Josh, what do you think I ought to do next?
Find the upper and lower control limit.
Okay, how do I do that?
Don't know the equation off the top of my head, but I know you have to use the C bar and add for the upper and subtract for the lower.
Okay, well, we're definitely on the right track. Kyle, what do you think? You remember?
Sorry, I was on mute. So it would be C bar plus. No, I was gonna wait. I thought you were gonna type it in. So yeah, it's C bar plus Z, which is 3, times the square root of C bar.
Something like that?
Yeah.
Okay, super. So we're going to use this formula. We have C bar. We have Z of 3 right there. And so we're just going to do that. So this one, assuming that Excel doesn't give me any problems, I need to hang Z somewhere. Hang Z over here. Okay, C bar plus Z times the square root of okay. And then I'm going to do the same thing in reverse. I'm probably going to get 0 or I'm going to get some negative number, but I'm going to do the computations anyway. Okay, so I'm just going to park my 0 out there because, again, like before, I know that I can't have a negative control limit. And then from here, procedure is the same. 2.43. Okay, Ellie, do I have anything that's out of control either way, above or below the line?
I mean, yeah, there's those 2 points that are above the upper control limit.
I got this other one down here. Okay, anything below the lower?
No.
Okay, so that's these 2 days right here that Ellie is talking about. That's on day 18 and 19. Okay, so let's see here. So Gilbert, question 11, based on your chart, what's your analysis of Batman's performance?
Well, it's pretty, what's it called? Not uniform, but like it's pretty linear, except for the 2 outliers.
Okay, so are the comments on social media out of control or are they in control?
I'd say they're in control because the majority of the dots are underneath the dotted line.
Okay.
Well, the majority of the data points, I guess.
Okay. Yeah, we don't have 3 consecutive points outside the control limit. Okay. So let's look at question 12. Let's see. So Myra, what days on which days might have Batman whooped up on some bad guys in front of a large crowd, do you think?
I would say days 18 or 19
Why do you
because there's
say
more
that?
negative comments.
Yeah. So there's probably some, a lot of people standing around and he, broke some dude's arms and stuff like that. And, a lot of people didn't like it. But other than that, folks are kind of okay with him doing what he does. All right. Questions on any of this that we just did? Big or small? Okay, I think the main thing to highlight and quickly review is remember the strategic decision on what type of chart we're looking at. So when you do this under exam conditions, I won't tell you, hey, do a P chart, do a C chart, do an X chart or an R chart for that matter. You've got to look for those keywords and those hints. I think the big hints are number one, negative comments is a categorical variable. Okay. You either have a negative comment or you don't. If you do, you either have 0, 1, 2, 3, 4, etc. You don't have 2.3 negative comments, at least not initially. Okay. So that's the big discriminator in terms of X and R versus P and C. Once we see that we have a categorical variable, we're now in P and C land. And so the decision is P versus C. The next thing to evaluate in our problem, in our narrative, is there some kind of sampling or sample size occurring? And we don't need to overthink this, okay? Remember, a sample size is the amount of measurements that we're taking within a sample. With the Batarang, we had 500 measurements within the sample. Every night he throws 500 times. But here, this is open-ended. Complaints are just coming in. Another example is if you kept track of how many times I mess up during a class. I make a mistake. I can't get Excel to do something. I quote a formula incorrectly, something like that. There's no sample size there. You're not sampling me at random. You're just keeping track of how many times I make an error. And in that instance, that would be a C chart if you wanted to plot that. Okay. I can't really think of an instance in which that would be a P chart, but for my P chart, I always like to go back to my hotel example. So after 5 days of Myra telling me, yeah, we had 6 complaints today, I kind of start wondering, well, that's only the 6 people that we heard of. So Myra, I want you to survey at random, 30 people. And I give her a method to do that. And so we do that for the next week. And then that instance would be a P chart kind of instance where we're doing sampling and we're looking at those categorical variables of complaints. Okay. And again, we could do that with hits, misses, anything that's kind of a yes or no type of thing. Once we get into an instance where we're talking about a continuous variable, like I ask, let me stop talking about Myra for a second, but Ethan Green is working at the hotel with me. And I say, hey, Ethan, the waffle iron has to be an average temperature of, I don't know, 201 degrees. And so I want you to check that at the beginning of every day. And Ethan goes out and checks that every day. One day it's 202.5. Another day it's 199.6, and so on and so forth. And we take a look at that over a week. We probably have a sample size there too. Ethan probably checks it 2 or 3 times a day, that kind of thing. But that would be an X bar and an R chart situation because we have a continuous variable. Depending on Ethan's method of measurement, he could conceivably take that that temperature of the waffle iron out 4, 5, 6 decimal places to the right. Okay. But he's not going to have an even number, and it's not a categorical variable. If I asked Ethan, hey, I want you to check if the waffle iron is working, that's categorical. But if I'm asking him to check the temperature on it, that is a continuous variable. So we really want to get comfortable with framing the problem, and we'll do a little bit more work on that when we do our review. But if we can get really good about framing the problem, then the rest of it is really procedural. We establish control limits. We identify points that are out of control, either for the day or for the system. And then we do the appropriate interpretation on how we feel about the system. Okay? Questions on any of that? Questions, comments, anything at all? Okay, let me do one more thing before we close out for the day. I will post the solutions right after we finish this class today so that you'll have those to refer to. And with that, I'll hang out until we clear the call. If I don't talk to you, have a great weekend, and we'll see you on Tuesday. Take care.
See ya.
Professor Strauss, can you hear me?
I can. What's up?
I did the Pearson homework already, and for the chart, they were saying that like if 1 point was out of control, the whole thing was out of control. I don't know if that was correct or not, but
I don't, if for the problem, that's fine. But procedurally in real world, I think it's going to be defined. I've seen it defined a number of ways. So in industry, in different various points. So if you go out, remind me again what position you play, please.
I pitch.
Yeah. So, and how fast is your fastball on average?
I don't know, like low 80s, I guess.
Low 80s. Have you ever had a day where you were just throwing slow, like
Yes.
70s?
Yeah.
So if you had a bad day when you were throwing 70s, I wouldn't sideline you for the rest of the season.
Okay.
That's the analogy, you know what I mean? So,
Oh yeah, I got it.
so if you're up there on the mound and you're throwing and I'm clocking you and I'm like, dude, I'd probably say, hey, AJ, what's going on? And you'd say something like, I don't know, this girl won't go out with me, or I didn't do well on this exam, or Luke pissed me off, or, you know what I mean? But what I wouldn't do is be like, you're out of here, go join the lacrosse team kind of thing. And I'm making a silly analogy to real life. I think if you're on the job and you see one bad day, you kind of go, okay, and then see what the next day brings. And
So basically, just base it off the three in a row kind of thing, and then that thing's out of control.
yeah, that's
Like
kind
for
of
your
why.
like for the test.
What's that?
Like for the test, like if it's like 3 in a row, then it's out of control.
Yeah.
Gotcha. Okay.
Yeah.
I was just curious. Like on the Pearson, they're saying like if 1 point was out, then the whole thing was. So.
Yeah, conceptually, I just don't agree with that, because I've seen many times in life where people or systems just have an off day. And, let's say we're working for Frito-Lay and we're like, making bags and bags of potato chips, and we look at production reports at the end of the day and like it's way down. We're not going to run out there and stop production. We're probably going to call in some leaders and be like, did you guys notice anything funny? And folks are going to be like, no, or maybe yeah, or hey, let's just keep an eye on this, and we're probably going to give it a couple more days. Now, if we we have 2 more days pass and production really is not what it's supposed to be, then we're probably gonna, say, hey, let's shut everything down. Let's see what's going on, kind of thing. So if
Sounds good.
you know what I mean? That's just
Yeah, yeah.
that's just kind of what I'm trying to do is, and I don't know why Pearson says that. I'm trying to just get past the kind of Pearsonism to give you examples of real life, because to shut down production, whether it's taking you off the mound or shutting down a Frito-Lay plant, that stuff's expensive.
Oh yeah, for sure.
And I don't want to be like the boy who cried wolf. I kind of want to make sure there's a problem before I really take like action that can't be reversed, kind of thing. And plus, if I pull you off the mound after one bad day, I mean, what does that say about me? It kind of says, man, I don't have much faith in AJ, and I don't know if that sends the right message.
Gotcha. All right.
Sound good?
Sounds good.
Okay.
Yep,
Anything
thank you.
else?
Have a good weekend.
Okay.
Not good.
What's up, Hannah?